In this video we're going to be looking at linear functions, and in particular the distance of a line or the length of a straight line between its two endpoints. This aligns with exercise 4.03 in the textbook, starting on page 202. So we have this bit here from the textbook which says the distance between 2 points, x1, y1 being the coordinates of the first point, and x2, y2 being the coordinates of the second point, is given by d for distance, equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Below that they have a little picture of a diagram of a triangle with a whole lot of information on it. What we're going to do is look at how this triangle was constructed and where this formula comes from. So we'll go and construct the diagram ourselves. Now, here we have a linear function. Two endpoints and our x-axis and our y-axis. Now, our first point, our bottom left point, has aligns with an x value there and a y value there. So we have x1 coordinate, y1. So this bottom left point has coordinates of x1 and y1. Our top right point, aligns on our x-axis there and our y-axis here. And that has coordinates of x2, y2. So two different x values and two different y values. What they've done in the diagram then is whenever you have a straight line on any angle, you can always create a triangle. So we've got a vertical of the triangle and a horizontal of the triangle, and it's a right angle triangle. Now, why would we create a right angle triangle? Well, because then, once we have a right angle triangle, we actually have the three sides. Say we label these A, B, and C. Well, you can start to write things which might look familiar, like c squared equals a squared plus b squared. So, the Pythagoras theorem, the length of the hypotenuse squared, which is this length here, the longest side opposite the right angle, the length of the hypotenuse squared is equal to the length of the other two sides squared, or the sum of the squares of the other two sides, technically. So, now let's actually have a look at these things, these lengths. So our length A goes from here to there, our vertical A. And if we look at the coordinates of A, the y coordinates of A, this actually has a value of y2, and this has a value of y1. The height at the top, y2, and the height at the bottom, y1. So the distance A is actually equal to y2 minus y1. So that is the length of A. Now B, we have a length of across the bottom here. And as you can see, we've got x2 and x1 for our two ends of B. So B is actually equal to x2 minus x1. Now, if we take these values, A here and B that we discovered here, A is equal to y2 minus y1, we can substitute that into our Pythagoras. And B is equal to x2 minus x1, we can substitute that into our Pythagoras as well. What happens if we do that? Oops. We have c squared equals, well, A was equal to y2 minus y1, so a squared is going to be y2 minus y1 all squared. And B was equal to x2 minus x1. So we've got here c equals a squared plus b squared. C squared equals a squared plus b squared, sorry. So c squared equals a squared, which is y2 minus y1 all squared, and b squared, which is x2 minus x1 all squared. Now we can just simply, because we're not interested in the square of the distance of our hypotenuse, we want the actual distance, we can move the square root over to the other side, and we end up with y2 minus y1 all squared, and x2 minus x1 all squared. So we've got c is equal to the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So basically we take our two y coordinates, subtract them, take our two x coordinates, subtract them, and square each of those and square root the whole lot. Let's have a look at if we got what they started with. So they have here d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And we used a c and we named a and b the opposite way, but we got the same formula just written in a different order. So that is where the formula comes from. The next video will go through an example of how to use the formula.